Hello everyone, welcome back to the 5-Minute Tech channel. Today we will be talking about asynchronous event-driven microservice, and we will be doing implementation based on ASP.NET Web API, RabbitMQ, MassTransit, MySQL, EFCore and Docker. This is the part 8 of the series Polyglot Microservice Architecture based full stack development. So this is the overall architecture of the application that we are building. We will be focusing today on the booking service. So in event-driven microservice architecture, services communicate with each other by publishing and subscribing to events. And when a service needs to communicate with another service, it publishes an event to a message queue or event bus. Other services can then subscribe to that event and take appropriate action when the event is received. And this architecture enables services to communicate asynchronously, wherein services can publish an event and continue processing without waiting for a response from the other service. So in our booking service, we are creating a example command, which is the create booking command, that through web API service we are trying to save it to database, and we publish also an event called booking create booking or booking create event, and that is like a publish action to our event bus. Now event bus is developed on RabbitMQ. Now what is event-driven architecture? Event-driven architecture, EDA as we call it, is an architectural pattern that revolves around concepts of events. Here the asynchronous events define the flow of the system. An event can be any occurrence in a system that causes a change of state, and it can be a user action, a sensor reading or an external trigger. The components of the system dispatch and consume these events, and thus enables loosely coupled and highly responsive architecture. Now, what are the key components of event-driven architecture? Is event producer, event routers, and event consumers. Now, event routers can also be seen as an event hub or event stream coming in. But event producers are the sources of the event, and these are the components that bring about the change of the state. Event producers are like messengers that create messages to send everyone who's subscribed, and event routers are intermediaries that receive the event from the producer and they decide where to send them. They make sure that the event reaches the correct consumer, and they also act as a filter to ignore events that don't satisfy certain criteria or rules defined within the architecture. And the event consumers are the part of the system that are interested in those events, and they are likely like the subscribers or the listeners waiting for something to occur. Now event-driven architecture, again as compared to other architectures like a request response, we have the request response is synchronous, whereas event-driven architecture is asynchronous. As the name says here, the client sends a request to the server, and the server processes that request and sets back a response. The interaction is direct and works for things like fetching data from a database or making an API call. However, it's not suited for complex scenarios where multiple components need to react and act to events independently. Whereas EDA, on the other hand, is asynchronous, and it is event-based communication system. It reacts to change in the system state, and event works like triggers that cause reactions in different parts of the system. Various components of the system generate and consume these events without being tightly coupled together. Now moving to the comparison with the pub/sub. The publisher subscriber is an architectural pattern often used in messaging systems. We have message publishers or pubs who send out information, and there are subscribers or subs who listen to the topics they are subscribed to. All of these subscribers get the same message, whereas pub/sub is useful when the multiple part of the system needs to know when something happens. However, it does not cater to different types of messages, whereas in event-driven architecture act as a superset of the pub/sub pattern. It uses pub/sub as a tool, but covers more complex scenarios as well. The focus isn't solely on broadcasting one message to many, but it emphasizes reacting to a variety of events with different actions. We can have different consumers for different type of events, and thus allowing for complex processing. Now, what are the benefits of event-driven architecture? It is the scalability and independent failure. So, since it is decoupled completely, in EDA, services are only aware of the event routers and not each other. This decoupling allows services to scale and fail independently, and if one component experiences a failure, it doesn't directly impact the others, enhancing the system's overall resiliency. So in development agility, developers can focus on their specific service without worrying about the intricate details of communication between different other part of the system. And the event router handles the distribution of the event, which streamlines the development process and accelerates time to market. Also, the simplified auditing and policy enforcement. Having a centralized event router simplifies your auditing of the system activities and enforces the security and access policies. It becomes easier to control who can publish or subscribe to a certain events and secure sensitive data in transit and at rest. Also, there is a cost efficiency. The event-driven architecture is inherently efficient. It operates on a push-based mechanism rather than a constant connected architecture, where actions are taken on demand in response to an event. This reduces the need for a continuous polling, as I was talking about, and saving on the resources like network bandwidth and CPU utilization. Now, when to use event-driven architecture, wherein we need parallel processing, wherein you need to enable a single event to trigger multiple processes simultaneously and without writing a custom code for each consumer. Cross origin or cross region coordination, ideal for systems that operates across different organizational units or geographic locations. Now, integrating diverse systems, you have more than one type of system, facilitating communication between systems with different underlying technologies without tight coupling. Also, building system that requires audit logging. EDS can simplify building audit logs, as system communications can be logged as a part of the messaging infrastructure. So these are the basic use cases of event-driven architecture. Now, what are the drawbacks of event-driven architecture? The debugging can be complex because you need to send a message and you have a event bus taking that message and publishing it to different consumers, and it requires using observability tools like distributed tracing. Architecture ends up reflecting organization complexity because you have different subsystems talking through the PubSub model, and it increases the importance of documentation and cataloging of services, and it requires experience in managing cloud services like your PubSub to ensure stability and avoid any failures. So this is the overall view of the event-driven architecture. We will not get into the code and write the application, the booking service application around all these tech stacks which we have already discussed. So to begin with, we are back to the same place where we left from the last time, where we have this book my boat solution and we have all these folders in place. Here we'll create a new folder called booking. So I'll create a new solution folder called booking, and in the booking folder I will go ahead and create a ASP.NET Web API project. So I'll create a new project here. We'll name it as booking, and in the booking what we will do is we will go ahead and first of all save this one. We'll enable the container support and we'll keep all these settings controller. So this will be booking controller. Yes, okay, don't need this, and the remaining we will keep for the time being. Now we'll go ahead and create different folders inside this. One is entities, so let me first add a new folder, entities, and then we will create repository layer or repository folder, repository, and then we will create is messaging, and then so these are some of the folders wherein we have more code. So first of all, starting with entities, we'll create a booking entity. So we'll create a class which is called booking entity, and this booking entity will contain, I'll paste in the the properties here. So the properties will be these: the customer name, service type, and the timestamp. We will enhance this as we progress further in the project, but for now we'll keep this as basic entity set, and we'll add the DB context here, which is the booking DB context. So it is booking DB context, and in the booking DB context we will go ahead and add the DB context related stuff. So let me put in that. So what is basically happening here is we are getting the EFCore, and we need to actually get that references here, but basically what we are doing is creating those EFCore plugin code. So we'll go ahead and add the NuGet packages. So manage NuGet packages, and this should be 8.0.3. yeah, this should be fine now. Yeah, so let me save everything and get the DB context entity framework core and the booking DB context. This should be booking DB context, and this should be booking DB context. Okay, next is we will go ahead and add the configurator for MassTransit. So what we have to do is to create in the messaging we'll create MassTransit configurator. We'll create a class called MassTransit configurator. Now in this MassTransit configurator, this is something which we'll be injecting in the middleware. So something like we have to configure services, public static void configure service, this is, and we do not need so it is giving me IntelliSense, and let me take this one and correct some things here. So I'll remove this, I don't need. I will add a reference of MassTransit here, my consumer. I'll correct this code. I've added the code for it. The consumer will be a booking created consumer. This is a class which I have created. Now this uses iConsumer of MassTransit for the entity iBookingCreate, which is a booking ID, timestamp, customer name, and service type is what you will go into the broker, which is RabbitMQ. And here what I am doing for the consumer, I am just writing to a console and also to a file rather than calling another service. So there will be a separate module where the inventory APIs will be it will be pushed to that webhook of the inventory service. But for now what we are doing is to just make the consumer as a logger, where I am logging into the console as well as to the file, and then this gets booking created consumer is something which is wired up as a MassTransit transfer of the data, and it uses RabbitMQ context, and it has the host running on RabbitMQ running on local host, which I will talk about when I talk about the Docker file, and it has the receive endpoint of booking service where it is sending the booking created consumer context, and we are adding it to the services. So this is going to be configured in the middleware, and we'll go there now. So we are in the program CS file where we have added the basic stuff, and also one important thing is we have added MassTransit configurator and configure service, which we just talked about, which has the configuration for RabbitMQ data passing to the RabbitMQ. Now we'll go ahead to the repository layer and add the repository code. So in the repository layer I have interface booking repository, there is add sync and get all sync. from getting it from the DB, which is the booking DB context, and I'm trying to save and get the data from the DB. So this is the two method which we have written here, and after that we'll go ahead and plug in the middleware. So in the middleware we'll go ahead and write that out, so which is your so yeah, so we'll do an add scope and we will add the repository. Now moving on, we will make the correction in the app setting file. So in app setting we have to set up these things, which is so we have to set the connection string for our MySQL, which is going to be this one, and the RabbitMQ connection with the username and password and the queue name, and also the MassTransit properties. Along with that, we have the Docker file in place. We'll go ahead and use this one, which is having the build part of the project which we have created just now. So let's go ahead and build this once. So let's build this. Before running this, we have to write the controller methods, and the one which we will be focusing on is the save of the data, so which we are getting as a booking request, create booking. So it will be HTTP post, and then we will have asynchronous call, and it is of task action result create booking, the booking entity, not booking request, booking entity. We can create booking DTO, but for the simplicity purpose we are keeping it like this. And here what we are doing is this is not the code which we will be using. We will create a var save booking, and we will await the repository and add the sync. Now we have to inject the repository as well. Now this iBooking repository, and that will be a booking repository, and here we have to write a method private iBooking repository, and here we will have to do this one. So that's fine now, and then we'll go ahead and await, and this time we have to publish it. So we have to create the bus, so we have to create a iBus. So let me remove this, we don't need the logger right now. So private read only iBus, and that will be a bus. And then what we will have is, instead of this we will do iBus, this is coming, okay, and that will be a bus, and this is bus. Now this iBus is a MassTransit dialog, is from MassTransit, and a logical element that includes the local endpoint and 0 or more receive endpoint. Now this is what we will be using, so we will do a publish to this bus, and that is the iBooking create, and then what we will do is we'll create the new object from this, and that will be saved booking ID, timestamp, customer, saved booking. Yeah, this looks fine, and this is how it will be published. And then we will do a create, return the created booking. This will be the saved create booking, okay, name of create booking. So this is the controller method. Now let's go ahead and run this and see. So as soon as we run it, we are able to see that it is launching fine. Now let's go ahead and create the MySQL and the RabbitMQ in our Docker desktop. For that, we'll right click on the project and we will go to add, and we'll do a container orchestration support and click on Docker Compose and click OK. As soon as you click OK, you would be able to see certain setups which should be same as what you have in the Docker desktop. For me it is right, so I'll go ahead and click OK, and here you will get the Docker Compose generated. In the Docker Compose YAML file, you have to enter the specific composed command line so that you will get the instances of your service, as well as for the RabbitMQ and the MySQL. So I'll go ahead and paste that code here. So this is the Docker Compose for the services, which is one is RabbitMQ, one is MySQL, and then the booking which we have created right now. These are the three services which will be running. So with this setup, we'll go ahead and run our Docker Compose. So to make the services run, you need to do a Docker Compose up -d, and you should be able to, since I've already run it before, so it's already running for me. So MySQL RabbitMQ instance is running, and we will be running the booking service through our HTTPS, that is the Swagger, through the Visual Studio itself. Now let's go ahead and run this the web API and see if we are able to see the transactions going on. So first of all, we have the Swagger link here. Also we need to do is to launch our RabbitMQ. So let's go ahead and launch the RabbitMQ here. It is guest, so I'll go ahead and do that here. So here we can see our RabbitMQ portal, and let me tab this out. And also we will go ahead and see to launch the to check the MySQL, you need to just you execute the Docker command to get into the MySQL. We have a booking user and the password is booking pass, so we'll enter that, and this will take us to the MySQL prompt. And here we can see is we can do a show database. Show databases, and then we can do is use booking DB. It's changed, and then we can do is check the tables. So our table is our database is here, and if we do show tables, we will be able to see that there is a bookings table. And what we can do is we can just go ahead and trigger the web API, which will give us the result. So in the web API, I'll come here and I tried this out. So let me run this, and let me change it to 4D, and then just execute it so that we remember what it was. So it is 4D, and this will be test user, and service type will keep it as test. We'll go ahead and execute this, and you see we are able to save it successfully. Now if we come back to the RabbitMQ, and you can see that there is a queue message which has gone into the queue, and that message is something which got processed here. And then if we go to our MySQL, and you can do a select star from bookings table, select star from bookings, and if you do this, you should be able to see the 4D data which we just entered in the system. So this is how the whole flow works, wherein we created a web API project, and then we have pushed a message to the queuing mechanism queue, which is our RabbitMQ for the event as an event that can be consumed by other services, and also we made a call to database and saved the data into the database. So that was pretty much about the event driven microservice. And I hope you like the video. If you like the video, press like and subscribe to the channel. Have a nice day.